I'll sit in the corner.
We'll get better at this.
Bonsai.
Welcome to the Hackaday podcast. My name's Mike Szczys. I'm editor-in-chief of Hackaday.
Hey, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 116, 3 DIY instruments, 2 tickers, and a microcar. Normally we'd start the top of the show talking about news and what's going on, but we have a special guest this week. Tom Nardi is going to be joining us in the articles that you can't miss section. And so we're just going to jump right into the first hacks and we'll get to Tom later.
Bam! My first hack this week is from Zapta. It's a stepper motor analyzer that reveals all. This is a great do-it-yourself machine that replaces like $2,000 worth of normal stepper motor analyzer. And it does it with a black pill, 2 current sensors, a bit of an EEPROM, a nice screen, and some really great coding. Accompanying this, there's also a video linked in our post by Teaching Tech, where he breaks down both how to use the thing and how stepper motors work, which is really useful if you haven't messed around a lot with stepper motors. You should go watch that middle section of his video, get a good feeling for what it means when the current patterns look like this and that, and then you'll be all set up to use Zapta's tool and diagnose your own stepper motors. The nitty-gritty of driving stepper motors is something that everyone who has a 3D printer should know something about, but I think a lot of people don't. And it's worth taking a device like this that really just looks at the different current curves going into the different phases of the stepper motor. But from that, you can learn a lot about how your microstepping's working, about how much inductance the motor has, and how much current your stepper driver is able to push into it. Zapta's device also logs any time that the phases don't go in the right sequence. So this would be maybe when your stepper motor is so starved that it's missing steps. This thing can detect them for you. And it's really cool. It just plugs in line with your stepper motor. So you plug one end into your motor controller, other end into your stepper, and you can print. For instance, if you're running a 3D printer, you can just print as usual, and this will log the entire job for you. So you can see when the motor's going fast, see when the motor's going slow, see if you had any dropouts, any lost steps, see if the maximum current is meeting the motor's maximum current specs. You can adjust the maximum current. It's just basically the device you need if you need to play around with stepper motors.
I really like the modular design of the tool itself. It is kind of like a backpack for a black pill board, which is kind of a nickname for an inexpensive STM32 dev board that you can get from AliExpress and other sellers like that. It just solders right onto a footprint on the board, and then there's another footprint for the screen, which is a touchscreen that you'd source separately, and it has a few headers for the plugging the motors in, so that you can actually test them along with some current sensing chips and an EEPROM.
And it really is the software that makes this thing a standout, and Zapta did a really good job of kind of showing you what it is you need to see. And Teaching Tech's video does a great job of showing, for instance, what it looks like when your stepper motor has too high an inductance and you're trying to drive it too fast. And basically what this means is for a given maximum voltage you can shove into it, you can't push the current through fast enough. And so if you're trying to step the motor really fast, you can't energize the magnets with these oscillating back and forth currents as strongly as you'd want to. And that's where the motor starts going and it starts skipping steps. And that explanation plus diagnosis is absolutely beautiful with this. And kudos to everybody here in making that very clear. So if you've never played around with that part of your stepper motors, you absolutely should give that part of the video a look. One last thing before we leave stepper motors, if you are interested in microstepping and how different stepper motor controllers do that, A, you can diagnose it with this tool, but B, in terms of how accurate the microstepping is, you should absolutely check out an old post of ours from 2016, How Accurate is Microstepping Really? Moritz Walter did some phenomenal research on this one, and that's one of my favorite motor driver pieces we've run in the last decade.
I was really excited this week to see a handheld computer that looks just great. It is the Paper Pi is an ergonomic cyberdeck meant for thumbs. Christina Panos wrote this article about a project by A8SKH4. I'm guessing I'm supposed to pronounce that somehow, but I just couldn't work it out, Elliot.
Not his real name.
This is, as the title of the article suggests, based around an e-paper display, which I find quite interesting. This one's just a normal one, so it doesn't have like any kind of high-tech, super fast refresh rate on it, but at the same time, I think for what you're going to be doing with this, it might be just fine. It's running a Raspberry Pi on the inside, but where it really shines is the case design and the interface for it. You can think of it as kind of like a PlayStation Portable form factor, so it's 16 by 9 or something like that. You hold your hands on either side, and where your thumbs would be gripping onto it, there's a set of keys. The keyboard's split in half for that. It's a Miryoku keyboard layout. It only has 36 keys, so it's not your typical QWERTY. On the one hand, if you were trying to learn that keyboard layout, this could be good, but then on the other hand, you're thumb typing rather than touch typing. So I suppose being a QWERTY doesn't matter all that much. Anyway, it's nice to actually save the space here. When you look on the inside of this, it's really well laid out, but these are not custom boards. The screen itself is a module, and then the cool thing is the keyboards are done so well, but they're just perf board. And so you have momentary press tactile switches with some kind of cap on the top of them. And the 3D printed case is done just perfectly, so it looks like it's a membrane keyboard or something, more fancy than that.
Yeah, it's a really slick looking device, and I've always wanted to make myself a portable with an e-paper screen. So this is like totally up my alley. Plus the split keyboard on the sides. It's beautiful. What else does it need? It needs a GSM phone. So you can like text people with this thing, and then it probably needs an SDR. But I guess you could put one of those in the USB ports that are coming out the top. So that's actually probably better this way.
It needs acoustic coupler cups on the back of it, so you can lay your rotary dial phone receiver on top of it and turn it into a modem.
I'm so jealous, A, of the design, and B, of just an e-paper portable Raspberry Pi computer. I'm going to make one, but I guarantee it's not going to look this good. All right, next up, 3D printed laser scanning confocal microscope measures microns. This is a great video by Zachary Tong. A confocal microscope is an interesting beast. It uses a laser to scan whatever it is that you're microscoping, and it uses the focus depth to figure out how high the feature you're looking at is. And so it's like a scanning microscope that gives you a 3D map. This particular one is made on the cheap and simple, and he gets marvelous results given that. One of the most critical parts of a scanning microscope like this is that you're able to move the object that you want to look at very accurately and position it extremely precisely over not much distance at all. I mean, it maybe needs to move a millimeter up and down and a few in the X and Y directions. And for that, he uses the Open Flexure Delta 3D stage. And we've seen this used for a couple other microscope builds. And every time I saw it, I was like, yeah, it just doesn't move much. And this is the exact application for which it makes sense. It's absolutely marvelous. So loved seeing that. And Zachary's explanation of how the microscope works is really fantastic and maybe a little bit littered with optics terms, but it gives you some really great stuff to Google if you're not up on your optics.
This is like the mama bear of positional tables for microscopes. It doesn't move too much. It doesn't move too little. It moves just right.
Yeah, but it's amazing how well this thing works, given that, A, it's just a 3D printed thing, and B, it's driven by those absolutely horrible 28BYJ-48 geared stepper motors. And you could get these on eBay for a 5-pack for probably $5. And they come with these nasty, horrible driver chips to boot. And so this is really a very cheap build. Let me talk about the confocal microscope for just one sec so that you know what we're looking at. It's basically a blue laser on one side that he's got two lenses that spread the beam out and then re-parallelize, and then collimate the beams again, so that, like, if you think of the first one as kind of spreading the laser beam out in like a triangular fashion, the second one collimates it and makes those diverging lines go parallel to each other. It's then bounced through a two-way mirror down into the microscope lens, hits the object, reflected light comes back up from the object through the microscope lens again, passes the other way straight up through the two-way mirror, into another mirror, through a little pinhole, and to a light sensor. And so what you get is a laser spot that is tightly focused on the object, bouncing back up through this little pinhole. And if it's in focus, the light going through that pinhole is really bright because it's a nicely tight focused spot. And if it's out of focus, it's defocused, right? And so the amount of light going through the pinhole to the little photodetector behind it is not as much. And so you scan up and down and you find where the maximum brightness is, and that's where the image is in focus, and that tells you what the Z height is. Now you move the base around in X and Y while going up and down in Z like that, and you can map out the whole volume, I guess. I mean, it's a tiny, tiny little volume. It's a microscope.
Yeah, well, it's counting photons, right? I mean, that's like, I'm a photon wizard in this one. And that's really awesome. I mean, I think watching his explanation of where the beam goes and how that all works is awesome. But then it goes up another level when he adds in these little tidbits. Like, for instance, after you expand and then collimate the beam, he mentions that it's going to be slightly elliptical because of the nature of the laser diode itself. And so he passes it through a circular aperture, which filters out, the edges of that ellipse. And then my favorite, Elliot, was the pinhole. In this case is a piece of tinfoil with a pinhole in it. And he shows that he has a professional grade filter that he could have used for that, but it filters out too much of the light. And so in this case, the tinfoil actually works better. I've
made tons of cameras with tinfoil pinholes. It's marvelous. It's actually the best way to do it.
Do you use a pin? Do you just take a push pin and...
Yeah, and the trick to making it round is actually you put it on a slightly smooshy surface, a slightly compliant surface, and then you put the pin in there and then you rotate it a little bit and then you pull it out. And then you flip it over and you can kind of deburr the backside with some super light sandpaper. And then you take it and you put it on your scanner, just a regular scanner, because they get 2400 DPI. And you can use that to measure how big pinhole is. And then you know how much exposure you're going to get. And so you can actually go through this and make like 10 pinholes super quick in an afternoon. And you can get yourself a nice array of different possible exposures. Pro tip. Anyway, the point is, this one is full of pro tips. The end of this is a discussion of everything that's been difficult with this build. And this is the opposite of rapid prototyping. It's like slow, because you have to imagine he has to take however many exposures up and down the Z direction and then multiply that by however many steps he needs to take in the X and the Y. It's a lot. For the small images he was doing, it was like 63-hour runs for this tiny little fraction of a penny's surface. Every type of optimization you can make in terms of running the thing a little bit faster here or a little bit faster there really, really matters in the end. And he goes into kind of all of these details that you would only realize if you tried to build this thing, because in principle, it sounds really simple. Laser in, bounce down, up through the mirror, how much light got through.
This next one is an article Lewin Day wrote called Modding a Hot Wheels Car into a Radio-Controlled Drift Weapon. I have to say, I was a little turned off by the title on this one, Elliot, so I didn't really look at it when it first came out, but I'm glad that I went back to it because it is insane. This is starting with just a stock Hot Wheels car, like taking it out of the wrapper, and ending with a remote control car that you can drive around and is snappy and drifts and does all the fun stuff. But for me, the process of fabrication on this is just fascinating to watch. The entire front end of the die cast underbody is cut off with a Dremel tool, and then put back in with rack and pinion steering, independent suspension for each of the front wheels. And that allows you to do just have one of the tiniest servo motors to do the steering. And then the rear end is actually put on with some like sheet steel, it looks like. Elliot, kind of like the things that they would cut a solder paste stencil out of.
Sure.
Yeah, so they just mount the axle on that and with a gear on the axle. And I look at it, I'm like, how are they going to do the motor there? They end up mounting the motor behind the axle, so kind of like in the trunk area of the car. Add a tiny LiPo to this and your typical receiver for remote control vehicles, and you're off to the races.
How big are we talking about here? This thing it's like a standard stock Hot Wheels car.
Yeah, so, put your thumb and your finger out with a large pinchy space in between, and that's the size.
How the heck does any of that stuff fit in there?
I know, and then it doesn't end there either. So once, it's got to look good. Like, that's the thing about car modding, right? You want to impress with the visuals. Jakarta Diecast Project goes on to put paint stripper on the body of the vehicle because it was I think a cop car that takes all the paint off and then gets out the Dremel again and starts grinding down different spaces. Like, takes I think they call it a spoiler, the fin on the back of the car, takes that off and then puts on body compound, or maybe it's just resin, I'm not sure. And shapes a new, I guess, more aerodynamic spoiler on the back of it, and does a great paint job, puts on tinted windows. I mean, all around, it's just loving the attention to detail on this.
I love the images in this of it in the body shop, right? He's got it on, I don't know, it must be a bottle cap or something, and he's just holding it up and spray painting around there, and it's masked off. And if you're not looking carefully enough, it could look like a car in a body shop because he's got nice lighting and, low contrast background and everything. It looks really good. And then you're like, oh yeah, he's completely stripped and is repainting a Hot Wheels car.
Yeah, it looks like a tilt shift photo for most of the time he's working on it.
Yeah, totally.
Now, I looked at this and I thought, oh, this must be the same person that did that scratch build back in August that I raved about on the podcast. And it's not. That's actually a different maker. So I'm just delighted that there is this vibrant, small-scale RC vehicle modding environment that's going on. And I think there should be more of this. So if you're making these things, we want to see your hacks.
That's hilarious. I saw it. I actually thought it was a dupe when I scheduled it the first time. And I actually double checked to make sure it wasn't, because I'm like, oh, this guy again.
Yeah, well, I went and searched the name and I'm like, why did we not put the name for the person in the first time we did it?
Yeah, how did we screw that up? Yeah, exactly. Sometimes there's just something in the air. How many stock ticker projects do we have on average per week at Hackaday? What would you say, Mike?
2. Now we're up to 2.
You would say on average per week we have exactly zero stock ticker projects. This week, what? We've got 2. And they're both really cool, and they both have entirely different mechanisms. So they're both worth looking at. And I thought that was really interesting. I'll start off with the first one, DIY projects, build your own Bluetooth notification ticker. This was on a Russian forum, so you want to go check out the details in Google Translate. It's absolutely marvelous. It's got a servo-driven arm with a Chebyshev Lambda linkage to make it trace. That's what that's called. You've got a wheel on one side, and then it's got a little moving arm, and the exact proportions of those make the thing that's out on the end of the arm travel in a straight line, even though what you're turning it with is a wheel.
All right.
Chebyshev Lambda.
I've looked it up, and a Chebyshev Lambda is an actual thing. Elliot is not just trying to make fun of me.
What? Sir, I'm offended. Anyway, the point is, why does he want to drive a pen in a straight line? The answer is it's the x-axis of this ticker tape printer. The other part is just a little stepper motor and a rubber wheel that pushes the tape along. So the head goes kind of up and down, making the letters, and the other side pushes it along like a 8-pixel old dot matrix printer. How does it write? Well, it's got a Sharpie-like pen held in this movable arm, and then it's got a foot, for lack of a better word, underneath that's connected to a solenoid, and it goes tick, 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 and it pushes the paper up into the pen tip, and then the pen moves along tracing the letters out, and it pushes the tape through. It's an absolutely marvelous device, and I think it's all made out of wood. It looks like he hand cut the whole thing.
I don't know. I thought it was like creatively painted to look that way.
Creatively painted 3D printing.
Maybe.
I did too. Go
Now I'm
look
looking
at the
closely.
Go
yeah.
look at the post.
Oh, you're right. How do you do that? Just milled. It's got to be milled.
I looked at it and I was absolutely certain that it was 3D printed in, and nicely oldified, but I think it's actually
Is it wood infill?
It's actually cut out of wood.
Is it wood filament? I don't know. That's weird. It's Russian wood. That's why, Elliot.
It
That's
looks
why it looks so different.
super plastic, doesn't it? Anyway, it's a marvelous ticker tape telegraph. I don't know what machine. Oh yeah, it's got Bluetooth, right? So he slaps in one of those HM5 boards in there. So it's got Bluetooth. Anything you type to it, it types out, but slowly and loudly. So fantastic. Which brings me to the second one, which is, whereas this first one appears to be anyway made out of wood, the second one is firmly steampunk. Secret bat caves. Build an ESP32 stock ticker to watch your GME gains. I'm not sure that's why he was building it. It's in a kind of like bell jar thing that he got from IKEA, and it has, instead of a pen and a crazy mechanism, it has a type wheel, an embossing type wheel that has all the letters on it, and two solenoids that drive the little platen underneath them and go ka-chunk and push the paper up into it. The Y motion here is a little bit janky and not as smooth as the Russian one, but he makes up for that by having a more elaborate mechanism that requires inking, if you think about it. So there's no pen on this one. It's this big wheel that has the letters embossed in it, and it goes over, I think, an inked roller of some kind to keep it always new ink on the letters. And so it spins this big wheel, the embossed Y comes up on the bottom, it goes chunk, and then it goes to the next one, and it prints it out that way. Also a lovely effect. Which one's your favorite?
I definitely like the Chebyshev Lambda.
Oh, yeah.
Much better. I mean, I look at that one and I was immediately like, oh, I can build one of those. I've got a bunch of those hobby servos around. But
yeah,
then it's three different mechanisms, though. So you have a roller mechanism to advance the letters along the tape. And then you have a solenoid mechanism from the bottom, which I think it needs to be solenoid so that it doesn't matter so much how calibrated it is with the tip of the felt tip pen.
Yeah, you just want to bonk it into it.
Yeah, and that bonking, it's magnetic. So if you don't use too strong of a field, you're not going to kill your felt tip pen.
Right.
And it's got kind of the springiness is going to be forgiving. But then the Chebyshev Lambda that is now my favorite word, Elliot. Thank you. that one uses the servo, but so three different mechanisms all working in a very clever way, and what comes out of it is very clear characters.
Yeah, and plus it's got a little bit of that robot arm thing going on, right? Because it's moving the pen around. So what's
like
not to love?
Fully articulated arm that only has one muscle on it. It's wild.
But the other one's got like this giant mini Ferris wheel with the letters on it that spins around.
And the sound.
And the sound, and the bell jar. I don't know. The other one I think is on MQTT too. So one's Bluetooth, one's MQTT. Man, if whatever your favorite flavor of stock ticker is, we've got it for you this week.
All right, bringing up the rear on Citizen Science Tools is the coolest spectrometer. This is the pi-based spectrometer, puts the complexity in the software. And Les Wright built this thing out of a Raspberry Pi camera, a closed circuit video zoom lens, and a diffraction grating spectroscope. So spectroscope, not spectrometer, because you're just supposed to look through the spectroscope yourself and then see the visible light absorption lines in there. And then like in physics class in high school, something like that, and make some kind of, guess at what's going on that's not very well metered, which is why it's a spectroscope and not a spectrometer. Except When you attach it to the Raspberry Pi camera, you can then capture that image and use it to characterize what is actually being seen. And the thing works awesome. We get to see it viewing different colored laser dots and then analyzing what the wavelength is there. There's some like, how accurate is it and how do you calibrate it questions there. But the fact is, you have a much more useful tool for pretty low price. I mean, you can get one of these spectroscopes for under $100.
Yeah, and calibrating, it's not so bad either. I mean, you probably have some light sources of known emittance kicking around the house. Like if you've got a fluorescent light bulb, those have some pretty regular peaks. If you've got, a 455 nanometer laser, one of those blue laser diodes, you know where that is. You probably have a red that you have a reasonable guess what it is. You could totally calibrate this. That's no problem. And this is just an awesome device. There's some great comments. I think Les himself gets into a question and answer with Arthur Wolf in the comment section here, talking about how to increase the resolution of it. And Les thinks it's actually limited by the diffraction grating he's got there. Maybe you could replace it with a prism and you could get more resolution there. The problem is the diffraction grating is made, of course, by having lots of little lines. And so you can't resolve anything spatially much bigger than the difference between these lines. And so there's kind of a limit to how fine-grained you can tell exactly where the spectral peak is at. So that's the first thing that would be really cool as an add-on, is swap out the grating for a prism. And the other thing, of course, is to put a calibrated light source on it, which gives you a spectrophotometer. And that is something that lets you figure out how light transmits through something. So you take a calibrated light source, you put a cuvette, you put a little test tube of your favorite test subject in the middle of it, and you see what kind of light it absorbs and what it doesn't. And that can tell you a lot about what kind of goo you've got in your little test tube. All right, my first quick hack this week is Stefan and his YouTube channel, CNC Kitchen. Texture adds stiffness to 3D parts. Idea Maker has come out with a new slicer that lets you easily emboss surfaces of 3D prints with patterns before you print them out. And so a bunch of YouTubers have been looking at this and playing around with it. Stefan is interested in how much strength it adds to 3D printed parts. If you've seen corrugated cardboard or wavy tin roofs or the side of shipping containers or basically anything made out of thin metal, it's always got waves in it to give it extra longitudinal strength. He's doing the same thing here with 3D prints and gets good results. Next up, where we're going, we don't need keycaps. This is a marvelous DIY keyboard by Peter Lyons. It is not a keyboard like you think. The squeeze box has got the keys, instead of being all on the same plane, they kind of wrap around your fingers. So you push your finger forward to get the top row and you pull it back like a trigger to get the bottom row and press down for the middle. This is a really awesome ergonomic experiment, and what makes it even better is that it's completely customized, completely 3D printable, and it's got screws to adjust all of the keys' location. If you've ever seen a data hand, this is like 2/3 of that for a lot less effort. If you haven't seen a data hand, we've got a great article. I'll throw the links in the show notes. And last up, Jenny List wrote an article, WSPR Whisper may hold the key to the MH370 final position. This was that Malaysian Airlines plane that went down and was never found. They didn't even get the black box out of it. Nobody knows where it went down. The idea here is that Whisper, which is a low-power ham radio propagation network, could have picked up reflections off of the plane. And so a transmitter in South Asia somewhere would get a stronger signal through to Europe if the plane was in exactly the right place. And hams have the logs for this. So a few people are going to start looking through the old data and see if they can figure out where it is. If this sounds far-fetched to you, you should know that hams do the sort of trick going way back, meteor burst transmission, where you bounce radio signals off of meteors as they're coming through and ionize the atmosphere, is actually a really old hack going back to the 1930s. And in modern times, you can do airplane scatter like this on purpose by looking up where the planes are, figuring out if it's halfway between you and a friend of yours, and then bouncing the signal off of the plane back down to them. Good fun, and this is a great idea to solve an unsolved mystery.
KE4MCL had some rusty screws and wanted to polish them up. But who has a vibratory polisher on hand? Nobody, but they built one really quickly by putting sand from the backyard in a jar and putting the jar on top of an upturned speaker. If you bump the bass, you can polish your screws. Next up, run out of GPIO on your Pi? Don't despair. I don't know, I wouldn't necessarily say this is a great place to get extra GPIO from, but the point is that Jay Wolfke wanted to have PWM control of a fan that was doing the cooling on the Pi, and ended up tapping into one of the pins on the camera connector. I think it's called a CSI connector. It's the thing that's kind of down towards the USB ports on that edge of the board. And pulling that off, ended up finding it worked great, and was surprised to see that the fan just barely needs to be running to get the kind of cooling that makes all the difference. And finally, Auto Ball Launcher will be your dog's new best friend. Connor Benson built this awesome tennis ball hurler. It uses a couple of rather large brushless motors with a couple of wheels that are 3D printed through several iterations to be just the right shape and grip. I think it's interesting because by powering both of them, I think you can kind of tune the altitude that the ball is going to take off depending on how fast the two wheels are spinning compared to each other. It is just kind of the first iteration, like the tosser has been built, but the hope is that for this good boy who plays out in the backyard, they're going to put some kind of funnel on there that the dog can drop the ball back into. The thought is that your four-legged friend can just keep loading it up with the ball as long as they're in a playful mood. It's time for the Can't Miss Articles of the Week. This week we have a real treat because Hackaday's contributing editor Tom Nardi is joining us. He actually went to a live event last weekend. Can you believe it? The VCF Swap Meet was taking place, and he wrote an article about it in a Hackaday, and we thought we'd have him on to talk about it. Tom, welcome back.
Thanks. Great to be here.
So tell us about how did you find out about VCF Swap Meet, and what's it like to be out in the world right now?
I think I saw it on their mailing list, actually. And it should probably be said, like, this was the second one. The first one was around this time last year, and they kept it a lot quieter, so they didn't even put it on the mailing list. I guess you had to know the secret handshake or something.
Right.
But this time they let a few more people know. You know, I had a really great time. It was nice to be among people again. This is the first thing I did a year easily. They took the reasonable precautions. Everybody was kept separate, masks on. I mean, it was outdoors, nice day. So it was good. Everybody felt comfortable, and it was just nice to be able to chat and look at cool old computers and just act like the world was semi-normal again.
So this was a swap meet for like retro computers / old computers. How old is old?
So that's the excellent question, and honestly, I didn't even know until I got there what the goal was. I mean, it's okay. So it's called the Vintage Computer Festival Swap Meet, but that's also the name of the organization, right? So,
right.
So is it vintage, or is it just called that because they're the people running it? And it wasn't super obvious to me, so I didn't know what to expect. But I would say when I got there, things did tend to have a little older twist to them, say the 80s and that sort of thing. There was nothing with toggle switches or lights on the front.
It depends on what's vintage to you, right?
Right. Yeah. I mean, there were some people saying like, "Oh, this stuff isn't old enough. This isn't vintage. This is just Commodore's not
Commodore
vintage."
64.
Yeah,
I have two of those in my closet. Yeah.
Wait, well, I thought about that though, and so I was like, well, what is vintage? Can you buy a 486? But then I was thinking, like, if you wanted to do something to see how a 486 system ran, I mean, you can emulate it, whatever, but like, where are you going to go to get a 486 these days? That is like a swap meet item, right?
Yeah, there was definitely stuff from that vintage. It sort of skipped, I guess, the 90s, because like you said, the 386, 486, they were like, it was. The older stuff, like I said, was more 80s, and then it went from there right to like modern Macs and that kind of thing. Probably, like you said, it's so easy to just virtualize stuff like that. Plus, who wants to use a 486? Like, what do you?
Exactly.
What do you
play
really?
Doom?
I think DOSBox would probably meet whatever requirements you had. It's
Yeah, for sure.
You know, now that I said that, I'm sure somebody is sitting at their 486 getting real mad.
Somebody with a big old ISA card
Yeah.
is saying, "You can't emulate my hardware."
Yeah, how dare you?
I see in the pictures there's like a bunch of Apple IIs and Commodores.
Yeah,
and
yeah.
It's an SE30 in some horrible state. My God, what did they do to that? Run it over by a truck?
No, I was surprised that you can get a in-box working Commodore 64 for $50.
What?
Yeah, some of the stuff was super cheap, definitely. I've always liked just the bins of broken computers. I don't know, maybe something's wrong with me, but that's what I look for when I go to these things. I want to see them just looking just the worst, and maybe a little tag that says, you know, make me an offer on this box.
Oh, you got to swing by my place.
Yeah, maybe buy 5 of them, and maybe one works in the end.
I want one of those super old luggable computers with I'm looking at one now. It's an Osborne. It really is an Osborne. With this like tiny little CRT screen, little 5-inch CRT screen and 8-inch floppy drives, or, you know, something like that. Dude, that's awesome. That would be a great, I know this is sacrilege. Oh God, I'm not going to say this on the air. That would be a great case to put something cool inside.
Oh, no.
Yeah, there was a couple of the luggables there. A few that I hadn't even seen before. I saw one of those, was it the compact, whatever one they had, where like the plasma screen kind of like lifted up out of it. But yeah, I think they're rare enough to tear them apart and put something else in them. It's probably not cool, but you know, I mean, hey, if you bought it, I guess no one can stop you, right?
If it was $50, you know, how not cool is it? That puts an upper ceiling on how uncool it is to do it.
Now, looking at the picture on the top of the article, like, this is a pretty good pandemic activity. You know, they've got a parking lot where people are just like pulling up into parking spaces and throwing open the hatch back of their vehicle, and then they like put a table out in front of it, and, you know, parking every other space kind of keeps things spaced out. And then if you're the vendor and you're standing on one side of the table and people are on the other side, there's space there. They're all wearing masks. It worked out pretty well. I'd love to see this sort of thing as, like, you know, hacker spaces start to come back together in this sort of thing.
I've mentioned that in the article I did for it. You know, it really felt like those old computer shows of like the 2000s or so. Where they like, you know, sometimes they'd be in like a convention center or whatever, but plenty of times they were just a parking lot and people would just open their trunk and say, here's some stuff. And they don't really happen anymore. You know, we have Amazon and eBay and all that. So that sort of went away, but walking around and talking to people and seeing what was on sale, it kind of made me nostalgic for that. And this is, you know, a good enough reason to bring it back, right? Like, we can do outside stuff as long as the weather's holding. I think it'd be cool to see more of this. And I'd like the success of this to kind of spread to other groups, or at the very least, you know, have VCF keep doing it. You know, I hope it's not a one-time, or second time technically, but I hope it's not a 2-time event. I'd like to see them keep doing it even after, you know, things settle back down. It was just really good to get out there and walk around and see what was on sale.
Did you buy anything?
I bought more than I expected to buy.
How many fingers is that?
I officially had no money when I left. Like, I didn't intend on that, you know. And there were some people who kind of said that too. Like, they weren't sure what to expect. You know, there's a lot of uncertainty going on, so they said, "All right, you know, I'll bring $20, $30." And it turned out there was a lot of people, like a lot of sellers, and people were running out of money.
That's awesome.
And the way it's set up over there, you know, the place used to be a military base that they've like converted into like the science campus or whatever. So it's by nature far away from everything else. Like, you don't just leave and go somewhere on the corner and hit an ATM. So, like, if you're out of money, you're out of money. So you got to get in the car and just leave and hope when you came back it was still there. You know, I'd like in the future, I understand that they wanted to keep their overhead low and they didn't want to get too involved, but it would be cool to see, you know, like a mobile ATM or something in the future. A lot of people had said that too, like even like a food truck would have been nice, because it was literally just a parking lot and tables. So maybe if they're going to keep doing it, you know, to have a little bit of civilization would be cool.
Well, given the way this one worked, it sounds like they have the success to believe that it'll be that successful next time.
Right. I mean, listen, they have limited funds. They do a lot.
Sure.
You know, everything's from donations and stuff. They didn't want to get themselves in trouble with this. But now that they saw how many people were there, I would think that the next time around they'd feel more comfortable to put a little bit more into it. And who knows? You know, it could grow separate to the regular VCF shows. That'd be really cool. Like a summer swap they do or something.
Yeah, good idea.
Well, we're glad you got out there to see what was going on, Tom. I'm sorry about your pocketbook, but hopefully you'll have plenty of good retro hardware to tear down in the future. Thanks again for coming on the podcast.
Hey, it's awesome to be here. Always good to talk to you guys.
Moving on to another great article this week that Adam Zaloof wrote. Ask Hackaday, why make modular hardware? I think this is a really good question, and it sparked a good conversation in the comments because it seems like when you conceive of building modular hardware, like for a smartphone, you think to yourself, oh, well, if the battery is bad, I can just swap in another battery. Or if I crack the screen, I can swap in a new screen. Or if there's new camera technology and I want an upgrade, I can swap that out. But there are a lot of trade-offs in something like that. And so we never see it come to fruition because people are really hard on their phones. The whole thing tends to kind of go downhill through heavy use and you end up wanting to just upgrade to the newest thing. But, the question should be out there, like, where are the good places for modular hardware? And I think Adam did a good job of highlighting a few of them. One of those places, Elliot, was educational hardware.
Yeah, I think we all have this like Lego thing in our minds, and then combine that with, those of us who have built computers for ourselves over the past. You swap out the old hard drive, you put in a new one. It's great to be able to upgrade these things as you go along. And then you also kind of just want to put these things together and feel like you can customize them easily. And I think that speaks to it a lot. And of course, then once you get to the education toys, like you were suggesting, it is the putting of it together that, makes the circuit or whatever. So in that case, kind of the modularity is necessary and kind of baked into the educational experience.
When Adam mentions that Snap Circuits toy, and I've purchased that for my nephew as well, and it's a really cool thing. It's a snaps like you would have on clothing, except for they complete circuits. And so you have modules like resistors and capacitors and LEDs and speakers, and then you have connector boards that snap onto them. To me, it's really kind of the same thing that's going back to the, I guess, 50s and 60s, where you could get those 301 electronic or radio experimenter kits, and you would hook it like wire to wire. It's the same sort of thing where you're never going to have a persistent object, but that's not the point. The point is like to start from just a few components and end up with a crystal radio that you can listen to.
I think there's something really fundamentally different in scale and in aim between something like a modular cell phone, which I would say that I want, at least one where I can swap out the battery, maybe the screen when I break it easily. Although, honestly, I won't lie, my cell phone's old enough that I can swap out the battery and the screen if it breaks.
Right.
But, that's one thing where it's kind of an expensive device and you're looking at repairing it versus something, that's basically, a toy or an educational kit. Or there was this other platform that he mentioned, the Pocket Project, which is basically like kind of the same sort of plug-in thing with an ESP32 or an STM32 as a brain, and then a bunch of little sensor and display blocks. I mean, that sort of thing is really appealing to me on one side, but then for a totally different reason from why I want modularity in my cell phone, right?
Well, so let's explain it first. This is really cool. It has this grid on the top of it of plus-shaped copper pads. And so, and I believe there's magnets embedded under the surface. And so each module can go onto one or several of these plus-shaped pads. And I built into the Linux kernel, it's going to recognize you like hot plugging these devices as like being new hardware that's coming onto the system. And so like it just works. And like that is really cool, the fact that it was built and the way that it works. But then when you start to think about your use case, like I'm going to drop this on my way to the kitchen and all the modules are going to fly off, right? Like that's an issue. Someone else in the comments is like, it's very cool, but when you do this modular stuff, you add a lot of space because you have to have like the walls of the case for module and for the host board itself. And then you have to have the robust connectors and they have to work every time. And like, it just takes something that's meant to be portable and really builds it up.
Yeah, I've suffered through this myself. I built this demo board for the Logic Noise series, and I had this like fundamental design problem. Should I just put everything, about kind of 10 independent circuits, all on the same circuit board and just leave connectors there for you to put across? And that's what I ended up going with. And I regret it. I should have made them all in a bunch of little modules that you could all plug together. But then the opposite side of that is you have to figure out how you're going to power them. And that makes like 3 times the number of wires you have to run. And so the whole thing ends up being a horrible rat's nest on your desk because I don't have the kind of elegant plug solution that something like this Pocket project has. I think designing this kind of modularity, like you say, it's hard. It's an art in and of itself. It takes up a lot of real estate. It costs a lot. You really have to be all in on the modularity to make it worth the extra expense, time, design overhead.
You made me have a eureka moment, though, Elliot. The most successful modular hardware out there is the Eurorack.
Yes.
Like, that's what you were just explaining with the logic noise, that the success is the Eurorack because it's, it's a standardized size and shape. Everyone kind of wants their own customized thing, and it's not just like one size fits all. And you just wire them from one to the next using whichever modules you want in it. Like, that's got to be the most widespread modular stuff out there.
Yeah, and the cost of that, I guess, is that the first thing you do is you have to buy a case, and that's going to set you back $100. And then the next thing you do is you have to buy a power supply and distribution board, and that's going to set you back another $200. And then you start adding the cost of all of these little boutique-y modules into it. I agree that it's that standardization and modularization is good, but it ain't free.
Well, but then we look at computers, because that's what I was thinking was the most successful modular thing was like desktop. I still use a battle
desktop
station
PC.
in my home office. Yeah, desktop PC. I can buy things. They all go together. I know they're going to work because there's specs for them. But the thing about it is, once I build the computer, I don't change it. Like, I built this thing in 2017. It's still going strong. I don't need a new anything. And by the time I get to the other side of it, I think the last one that I used, I must have been using for at least 7 years.
Oh, but I so appreciate that swappability. My wife was just like, my hard drive's full. Get me another one. And instead of having to make up some elaborate backup system and think real hard, you just buy another hard drive, plug that sucker in there, swap things over until it works, and then you can unplug the old ones. That sort of modularity, swappability is fantastic. And I hear you. I haven't swapped out a processor in a desktop computer since like 2002. But, you could if you wanted to.
Turn your ire on Apple on this one, right? If you look at their MacBooks, going back to at least 2016, they've been soldering the SSD on. So like the storage is soldered onto the board and RAM's soldered on the board. And there are other makers out there doing this because you want a robust machine. You want it to be very thin and sleek. You don't want to have heat problems. You want to hit a price point. All these reasons for doing it, but you really get bit by it when your SSD conks out and you need to buy an entire new computer. So where do we come down on this? I think modular hardware is like a romantic poem, Elliot. It's an ideal you strive for, but you never actually get there.
Lovely.
That's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment on the show notes, which you'll find at hackaday.com/podcast. You can email us, editor@hackaday.com. We live and die by the tips that you send us, so if you see something cool or you've done something cool, please let us know about it. tips@hackaday.com. And until next time,
keep on hacking.
Mistakes today, Elliot. Ooh, mistakes.
Ooh. Think breath of fresh air. Think rejuvenating the Hackaday podcast.
Wow.
And that means this week we've got me trying to think of a good transition.
It is the interesting thing. This is a Mirio. Ooh, I can't do it.
I think you said you should solve your problems with software. Now you have 2 problems. Which one was this? Oh yeah, this is the bizarrest.